Good afternoon, everyone, and happy Friday. Welcome to the TV Happy Math Hour, our weekly interactive math reviews for the Math 1314 and the Math 1324, presented by Ms. Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later and watch it. Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information that will be shared.
Hello, everyone. Welcome to Friday Happy Math Hour. So today will be the last session for uh, this 5-week session, and we're gonna go over the final exams. So some of you are taking your exams soon, and if you're in 1324, they'll put a link for you to go to the other class. So we'll get started. So here we have find any intercepts and test for symmetry. Okay, so let's go ahead and do the X-Intercept first. So in order to find the X-Intercept, remember that we want to let y equal 0, and then we solve for x. So here's my equation. If y is 0, I solve for x, so I'm going to subtract 1 on both sides. And then I'm going to divide by -2 on both sides, so I get x is equal to a half. And so our point is going to be a half for x and 0 for y. In the same way, to find the y-intercept, now we let x equal 0, and then we solve for y. So here, if I let x equal 0, -2 times 0 is 0, plus 1 is going to give us 1. So our point is going to be 0, 1. In order to graph a line, we can just use these 2 points here. Okay, so that's how we find the x and y intercept. Now we want to look at symmetry. So if we look at the graph, if I was to graph this line, then we can see if it has any symmetry. And the other way to figure out if there's symmetry is to do it algebraically. Okay, so number one is you can graph the equation and check for any symmetry here, or you can also find it using algebra. So to figure out if something has x-axis symmetry, we're going to take our point here and we're going to switch our y to a negative y. So in the equation, this is my original equation. I'm going to replace this y by a negative y. Okay, so I've done that here. And then we're going to solve for y. So if I divide by -1 across, then I get y is equal to 2x minus 1. In order for it to have symmetry in the x-axis, this equation that we got here has to match your original equation. So our original equation was y equals -2x plus 1. And the result after we switch the y value is y equals 2x minus 1. So if you notice here, these two equations are not the same. Therefore, we say that there's no axis symmetry. So let's go to the next one, the y-axis symmetry. For this one, we change the x to a negative x. And so here's my original equation. And now I'm going to replace the x with a negative x. So if I simplify -2 times -x, positive 2x plus 1. And again, if we compare, this last equation is not the same as the first equation. Therefore, it has no y-axis symmetry. And then for the origin, we would have to change the x and the y. So here we have a negative x and a negative y. So in the original equation, this y will become a negative y, and this x will become a negative x. So if we simplify, negative times negative is positive 2x plus 1. And then we divide by negative on both sides. So we end up with y equals -2x minus 1. So again, this last equation is not the same as the first equation. So there's no symmetry on the origin. Okay. Now in section I think it was like 1.2 or 1.3, it's asking us to write the standard form of the equation of a circle given these characteristics. So the center, they tell us, is -4 and 2, and the radius is 2. So I always like to start by writing the standard form of a circle. So this is your equation: x minus h squared plus y minus k squared equals r squared. And recall that h and k represent your center, and then r is representing your radius. So in our example here, -4 represents h, and 2 represents k, and then our radius is going to be 2. So if I plug those numbers in, I would get x minus h is -4 squared plus y minus k, and k is 2 squared, is equal to 2 squared. Then we keep simplifying. Negative negative is going to be a positive. So we get x plus 4 squared, and then we get y minus 2 squared equals to 4. So this is the equation of the circle given this center and this radius. Okay. This is still from chapter 1. So write the equations of the lines through the given point that's parallel and perpendicular. So if I have this equation, the first thing I need to know is what is the slope of this equation. So we're going to go ahead and find the slope here. So in order to find the slope, we want this to be written as y equals mx plus b. And so I'm going to subtract 8x on both sides, divide by -2. So -2 divided by -2 is positive y. 3 divided by -2 is -3 halves. And -8 divided by -2 is going to be a positive 4x. So from this equation, all we care about is the slope. So our slope here is going to be 4. So I'm going to go ahead and leave it over here in red. So now I can use my slope and the given point to find another equation that is parallel. The reason I'm using 4 is because parallel lines are going to have the same slope. So this equation had a slope of 4. So the new line that we're looking, if it's parallel, we're going to use the same slope. And so here we're going to use m equals 4 and our point. Then we can use the point slope form of the equation and substitute these values. So we have y minus y1 is 1, is equal to m is 4, x minus x1 is 8. And so this is the equation I get here. We're going to distribute the 4 into the parentheses, and then we end up with 4 times x is 4x, 4 times -8 is -32. Solve for y, so we're going to add 1 on both sides, and we end up with 4x minus 31. So this is going to be our equation, and this is a parallel line. Okay. If it's perpendicular, then you want to find the negative reciprocal of the slope of the first line. So the slope of the first line was 4. So the negative, so here's my negative, and then the reciprocal of 4 is 1/4. So now we're going to do the same thing, but instead of using 4, we're going to use -1/4. So we plug in our values. We have y minus 1 is equal to -1/4 x minus 8. Multiply the -1/4. So we get -1/4 x. -8 times -1/4 is going to be a positive 2, positive 2. And then we're going to add the 1. So we end up with 2 plus 1, which is 3. So this is our equation of a line that's going to be perpendicular to this line. Okay, so the next example is operations of two functions. So we have f of x is equal to 9x plus 1, g of x is equal to x squared minus 4, and we want to add the two fractions. So the first thing I like to do is rewrite f plus g of x the way it's defined. So this right here just means f of x plus g of x. Now I'm going to substitute what I know about f of x. F of x is 9x plus 1, so I write it down. And then g of x is x squared minus 4. And then we gather our like terms. So we have an x squared, we have a 9x, and then we have a 1 and a -4, which gives me -3. To subtract, again, it's easier if we write it the way it's defined. So we're going to have f of x minus g of x. So f of x is 9x plus 1, and g of x is x squared minus 4. We're going to distribute the negative into the parentheses. So negative times x squared is negative x squared. Negative times negative 4 is a positive 4. We can gather our like terms, so we get negative x squared. We have a 9x, and 1 plus 4 is 5. And then to multiply, again, I rewrite it as f of x times g of x. So I have 9x plus 1 and x squared minus 4. So 9x times x squared is 9x cubed. 9x times negative 4 is negative 36x. 1 times x squared is x squared. And 1 times negative 4 is negative 4. We check to make sure there's no like terms. So we end up with 9x cubed plus x squared minus 36x minus 4. And then the last one, division. So this is defined as f of x divided by g of x. So here's my f of x, here's my g of x. X squared minus 4, you could factor that as x minus 2x plus 2. But if we factored it, we wouldn't be able to cancel the 9x plus 1. So we can just leave it like this. This will be fine. And so that's division. And then the last question is, what is the domain of f divided by g of x? So to find the domain, you want to look at your answer here and ask yourself, is there any fractions? And we do have a fraction that has a variable. So what that means is that there's going to be some restrictions. And to find those restrictions, we set the denominator equal to 0. So x squared minus 4 equal to 0. If I add 4 on both sides, I get x squared equals to 4. Take the square root, so we get x equals plus or minus 2. So the domain can be any number except for 2 or negative 2. And so in interval notation, we would write that as negative infinity all the way to negative 2. And then we use the union symbol, which means that it's everything together. And then we have from negative 2 to 2, and then we go from 2 to infinity. So this right here represents in words that the domain is everything except for negative 2 and positive 2. And that's why we use parentheses instead of a bracket for these 2 and negative 2. Okay, another question is, does a function have an inverse? To determine if something's a function, you use a vertical line test. But to determine if it has an inverse, we can use a horizontal line test, which I drew here in red. And if this horizontal line test touches your equation, your graph in one location, then it's going to have an inverse. But if it touches in more than one, then there's no inverse. So this one has an inverse. Okay, so let's look at this example. Determine whether the function has an inverse function or not. So the first step is figuring out, well, to find the inverse, we can do the following. So this is a square root function, and it does pass the test, right? So let me just draw it really quick. Okay, so this is my x-axis or my coordinate plane. And so x minus 8 is going to be 5, 6, 7, 8. It's going to look something like this. Okay. And so if we were to apply the vertical test, it's going to be a function. If we apply the horizontal test, then it's only going to touch in one location. And so therefore it does have an inverse. So we can find the inverse. And the way we're going to find the inverse is as follows. So first, you replace f of x with y. Then to find the inverse, we're going to switch your x and your y. So here's a y, I switch it to x. Here's an x, I switch it to y. And then we solve for y. So in order to solve for y here, we can we can square both sides. So we get x squared, and then we have parentheses, square root of y minus 8 squared. So the square root and the power of 2, we like to say that they cancel in reality it becomes a 1, so we end up with just y minus 8. And then we're going to add 8 on both sides, so we get x squared plus 8 is equal to y. Once you solve for y, you change the y back to the symbol for the inverse. So here is f of inverse of x. It's going to be equal to x squared plus 8. So that's going to be your inverse. Okay. And then now we go into chapter 2. And so here this question is in 3 different parts. So I'll go ahead and just break it down one part at a time. So here we have apply the leading coefficient test, which determines the behavior of this function. And just as a reminder, I always like to consider these 4 graphs. And so if your exponent is even and the leading coefficient is positive, the behavior is always going to end up rising to the left and rising to the right. So if you're taking a 10-week class, then right now this week you're working on chapter 2 material. So this is going to be right on for you right now. So anyway, so if you have a even exponent with a negative leading coefficient, then the graph is always going to behave in this form, which is it's going to fall to the right or fall to the left and fall to the right. If you have a cube or an odd degree and a positive leading coefficient, then your graph is always going to rise to the right and it's going to fall to the left. If you have an odd degree with a negative leading coefficient, then you're going to rise to the left and fall to the right. So if we look at our example, we have x squared and we have an x. So the degree is your largest power. So in this case, 2. And 2 is even. Okay. So 2 is even. That means that our answer is either going to be this first graph or this second graph. So now we look at the leading coefficient. It's negative. So that means that the behavior is like the second graph here. And so that means that the graph falls right and falls left. And so let's see what answer choice that is. Function falls to the left and falls to the right. So it would be this one here. So it's the last one, letter C. Oops. So now the second letter B says find the real zeros. So anytime they ask you to find the real zeros, the first thing you want to do is set your equation equal to 0. So let's go ahead and do that. So 0 is equal to negative x squared plus 12x minus 32. And so since this is quadratic, you have options. You can either try to factor, and then just remember that not everything factors. Or you can use the quadratic formula. So here, I always like to try and factor, and I give myself maybe about 30, 40 seconds. And if I can't factor in that time, then I go use the quadratic formula. But here, it looks like we can factor. If you don't like this negative in front of the x squared, you could multiply everything by negative, and it would change it to x squared minus 12x plus 32. Having a positive leading coefficient just makes it a little bit easier to factor. So I have x times x is x squared, and then 32 is 8 times 4. Since this is positive, the signs have to be the same. So we have a negative and a negative will give me a negative 12x. And so these factors work. Once you have your factors, we can set each factor equal to 0 and solve for x. So I add 8 on both sides, and I get x equals 8 and x equals 4. So these are zeros. And then it doesn't ask you to do this here, but you also want to know if it touches or if it crosses the x-axis. If it only appears an odd number of times, then it's going to cross. If it appears an even number of times, then it's going to touch. Okay. So here we have our zeros. We have our end behavior. The other thing you want is the y-intercept. And the y-intercept is when we let x equal 0. And so here we have x is 0, x is 0. So we end up with y equals negative 32. And then the other helpful information is the vertex, which can be found using this equation or this formula here. So x is equal to b or negative b divided by 2a. So if we look at our problem here, b is 12 and then a is negative 1. So we have negative 12 divided by 2 times negative 1. So negative negative would be a positive 6. Once you find the x value, you plug it back in for the x's in your equation so that you can find the y value. So here we have negative 6 squared plus 12 times 6 minus 32. And all of this here, 6 squared is 36 times the negative 1 is negative 36. And so this is going to come out to positive 4. So my vertex is 6 and 4. Now that you have all of this information, we can put it together. So here's my vertex, 6 and 4. Here are my zeros, x equals 4 and x equals 8. The behavior is that it falls right, and it falls left. And then, of course, for our zeros, they cross at the x-axis. Okay, and we have another graphing one here in a second. So find the rational zeros of the polynomial function. Excuse me, there's two ways you can do this. The first way doesn't always work. That is to see if you can factor this. So we can check if we can factor. So for example, we can take out of an x squared out of these two terms. So that would give us an x plus a 1. And then over here, we can factor out a 9. And so it looks like it would factor. But if you're not sure on the factoring part, then you can use this method here. So it says use the rational zero test. The rational zero test means that we're going to take the factors of our constant term, which is 9. So the factors of 9 are 1 and 3 and 9. So basically, the numbers you can multiply together to give you a 9. So 1 times 9 and 3 times 3 give us a 9. And then the leading coefficient is 1. And the factors of 1 is just going to be 1 times 1, which is going to give us that 1. So we also include the plus or minus because we could have, for example, negative 1 times negative 9 still gives me a positive 9. So we include the plus or minus. And then if we divide, 1 divided by 1 is going to be 1. 3 divided by 1 is 3. And 9 divided by 1 is going to be 9. So in WebAssign, you cannot enter a plus and a minus. They don't have the symbol for this. So they ask you to enter it from smallest to greatest, separated by a comma. So this would be negative 9, negative 3, negative 1, 1, 3, 9. So what is this? Why is this method special, or why do we use this method? Is our goal is to find the zeros. And so there's so many numbers out there, right? Infinite numbers. So with this method, we make our list a little bit smaller. So now from this 6 numbers, maybe one of these will be a 0. Okay, I always like to start with number 1. And so I'm going to use 1, and I'm going to use synthetic division. So to set up synthetic division, we take the coefficients. So this is a 1, x squared has a 1, x has a negative 9, and then your constant term is a negative 9. The 1, again, I just got the 1 from, it's one of these possible zeros. So then we bring the 1 down. This 1, we bring it down. And then we're going to multiply 1 times 1. And then our answer, we write it up here. So 1 times 1 is just 1. And then we're adding. So 1 plus 1 is 2. And then we do the same process. 1 times 2 is 2. So I'm going to write 2 up here. And then we add negative 9 plus 2, negative 7. And then we go again, negative 7 times 1 is negative 7, plus negative 9 is negative 16. In order for us to say that this is a 0, our remainder, or our last number here, has to be a 0. But in this case, it's not a 0, so that doesn't make us too happy. But we know that x equals 1 is not a 0. So now we can try another number. Let's try negative 1. So same thing, we bring down the 1. -1 times 1 is -1 plus 1 is 0. 0 times -1 is 0. -9 plus 0 is -9 times -1 is going to be a +9. Plus a -9 gives me that 0 that I need. And so that's going to make me happy because I can say that x equals -1 is a 0. Okay. And what do I mean by it's a 0? Let me just draw it here really quick. So that means that if you're graphing at x equals 1, it's an x-intercept. Okay, so your graph is going to go through that point or it's going to touch it. So now that we have 1, 0, this degree is 3. That means we should have 3 zeros. So we have 1 here. So to find the rest of the zeros, we use the quotient. So to get the quotient, since your degree was 3, we're going to start with 1 degree less. So I have a 1, so that's going to be your x squared. I have a 0 here, so that's going to represent your x. And then -9 is going to be your constant. And so now this is my quotient, x squared minus 9. To find the rest of the zeros, we set it equal to 0. And I'm going to add 9 on both sides and take the square root. So we get x is equal to plus or minus 3. So my 3 zeros are -1, -3, and +3. Okay, so we're going to graph it. Let me go to the next page. So to graph this, first we plot your zeros. So we said 1 0 is at x equals 3, 1 is at x equals -1, and 1 is at x equals -3. So this dot should be right here. Okay, so let's let me try to change it there. So the dot should be here. Oops. It should be right here instead of over here. Okay, so now let me put the pencil away and let's continue. So once we have our lines plotted, then we're going to apply the end behavior. So this is a cube, that's odd, and then we have a 1. So since this is cube and this is a positive, then we know that the graph is going to rise to the right and it's going to fall to the left. Again, this right here should be at x equals -3, so it should be right here. Okay. And let's go on. Well, in order to get a good idea of what the graph should look like, now we can plot extra points. And the extra points that you can pick, it's really up to you. But if I pick a point over here somewhere, all I know is that it's going to be over here in the bottom. If I pick something over here, it's going to be on the top. But what I want to know is what's happening in between this area here. So some of the best points to pick would be a 1 and a 2, and a 1 and a -2. Okay, so I have them listed here. So when x is 2, we plug it into the equation and we get -6. And when x is 1, we plug it into the equation and we get -16. So that would look like when x is 2, we got a -6. And then when x was 1, we got a -16, so somewhere down here. And then when x is -2, we got a +5, so up here. And then we can connect our dots. Okay. So again, this graph should really be going through x equals -3. Okay. So now this is similar to the other one. Use the given 0 to find all the zeros of the function. So all I know is that one of my zeros is 4 plus 2i. So if you have an imaginary solution, then you can automatically say that the conjugate is also going to be a 0. So far I have 4 plus 2i is a 0, but I also have 4 minus 2i is a 0. Okay, so let's go ahead and find the zeros. So I'm going to take this information and I'm going to use synthetic division. So I'm going to use 4 plus 2i right here. And then my coefficient for x cubed is 1. My coefficient for x squared is negative 12. And then my coefficient for x is 52. And my constant is negative 80. So if we apply synthetic division, then we bring down the 1. And then we're going to multiply. So 4 plus 2i times 1 is just 4 plus 2i. And so this looks a little crazy, but we can simplify by adding common terms. So negative 12 plus 4 is negative 8. And then we have our plus 2i. And now we start the process again. So we're going to multiply 4 plus 2i times negative 8 plus 2i. So we're going to have 4 times negative 8, 4 times 2i, 2i times negative 8, and 2i times 2i. And it looks something like this. Okay, so we get 4 times negative 8, negative 32, 4 times 2i, 8i, 2i times negative 8, negative 16i, 2i times 2i is 4i squared. We know that I squared is equal to negative 1. Okay, so we have negative 32. I squared is negative 1, so times 4 would be negative 4, plus the negative 32 is negative 36. And then 8i minus 16i will give us a negative 8i. So we can simplify, and we ended up with negative 36 minus 8i. If we add it to the 52 plus negative 36, we get 16 minus 8i. And then we do the same thing. 4 times 16, 64. 4 times negative 8i is negative 32i. And then 2i times negative 8i is negative 16i squared. And so we end up with 64 minus 32i plus 32i minus 16i squared. So the negative 32i and the positive 32i become 0. And so we end up with 64 minus 16i squared. But I know that I squared is negative 1, so times 16 is negative 16. And 64 plus 16 is going to be 80. And if we add these two together, we get 0. So if you don't get a 0 here, then you know that we did something wrong, because since they tell us that it's a 0, we have to get a 0 here. Okay, so if we look at our quotient, this degree was 3, so we're going to start with 1 degree less, which is x squared, and that coefficient would be a 1. Then we have negative 8 plus 2i. That's our coefficient for x. And then we have our constant 16 minus 8i. So it still looks like a little crazy, but it's okay. Now we're going to do synthetic division again. So in front of x squared, I have a 1. In front of x, I have a negative 8 plus 2i, and then 16 minus 8i. But now I'm going to use the conjugate. So here we had 4 plus 2i. So my conjugate is 4 minus 2i. So I'm going to bring the 1 down, multiply times 4 minus 2i. So negative 8 times 4 is negative 4, or negative 8 plus 4 is negative 4. The 2i and the negative 2i cancel. And then we're going to multiply 4 times negative 4 is negative 16. And negative 2i times negative 4i is going to be positive 8i. So if we add these, we get 0. And so now our quotient, since we had x squared, we're going to start with 1 power less, which would be x. The coefficient for x is 1. My constant is negative 4. Set the quotient equal to 0 and solve for x. So x is equal to 4. So my 3 zeros, I should have 3 because the degree is 3, are x equals 4 minus 2i, x equals 4 plus 2i, and x equals 4. There shouldn't be a 0 here. So x is equal to 4 is my third 0. Okay, so let me change that really quick. So it should be a 4. not a 0. Okay, so using synthetic division can help us to figure out what these zeros are. So let's go on. And then now we have a rational function. So it says state the domain of the function. So the first question is, do you have a fraction? And if so, does it have a variable? And it does. So to find the domain, we set x plus 3 equal to 0. So let me go ahead and write it here. Okay, so x plus 3 is equal to 0. Subtract the 3. So x equals negative 3 cannot be in the domain. So your domain is everything except for negative 3. And so if we look at our solutions here, that would be letter D, all real numbers x, except x equals negative 3. So that was part A. Part B was to identify the intercepts. So the x-intercepts, we let y equal 0 and solve for x. So we're going to let y equal 0 and then solve for x. So if I multiply x plus 3 on both sides, then I end up with 0 is equal to 1, which is a false statement. So what that means is that there's no x-intercept. Okay, let's check for the y-intercept. We let x equal 0. So substitute 0 for x. So we get a third. So my y-intercept is 0 and a third. Now it says find any vertical and horizontal asymptotes. So let's check here. So remember that a vertical asymptote is a line that's going vertically through the x-axis, and we use a dotted line to distinguish it as an asymptote. In order to find the asymptote, you want to factor the numerator and denominator completely and cancel any like terms. If you cancel any like terms, then it creates a whole. Okay. And then once you factor out your common terms, we set the denominator equal to 0 and solve for the variable. And so then that's how we find the x-intercept. I'm sorry, that's how we find the vertical asymptote. Okay, so let's look at this example. So we factor both the numerator. Since I have a 1 that's already factored. So we have x plus 3. That's going to be already factored. And so we're going to set the denominator equal to 0 and solve for x. So x is negative 3. So x equals negative 3 is going to be your vertical asymptote. So we use a dotted line. Give me a quick second. Okay, so next we're going to do the horizontal asymptote. So as a review, a horizontal asymptote crosses the y-axis, and we use the dotted line again. And there's 3 different situations. So if the degree of the numerator is less than the degree of the denominator, then there exists a horizontal at y equals 0, which is your x-axis. If the degree of the numerator and denominator are the same, then we set up this equation, y is equal to the leading coefficient divided of the numerator divided by the leading coefficient of the denominator. And if the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. And if it's only greater by 1, then there exists a slant asymptote. Okay, so let's look at our example. So the degree of the numerator here is 0 because there's no variable, right? And then the degree of the denominator is 1. So the degree of the numerator is less than the degree of the denominator. So that means that it's going to have a horizontal asymptote at y equals 0. And so that's represented by the blue line here. And notice that it falls right on the x-axis. Okay. So once you have that information, then we're going to go ahead and graph the equation. This is everything we found. We said that there was no x-intercept. We found the y-intercept. We found the vertical asymptote. And we found the horizontal asymptote. And the last step is to plot additional points. But I encourage you to do it after you graph everything. So here is my y-intercept. Here is my vertical asymptote. And remember your x-axis here is your horizontal asymptote. So I need to know what's going on with my graph here. So I'm going to choose -2 and I'm going to plug it in. So I get 1 divided by -2 plus 3 is equal to 1. And then I'm going to use also 2. If I plug in 2, I get 1/5. And then maybe I want to know what happens on the left side of the asymptote. So -4, we plug it in, we get a -1. And then -5 is going to give me a half. So I believe I have the points here. So here we have our -2, which gave us 1. We had a +2, which gave us a fifth, 1/5. We had -4, which gave us -1, and we had a -5, which gave us a -1/2. So if we plot it, then our graph is going to look like this. Okay, so it's going to get really close to the dotted lines here and really close to the x-axis, but it's not going to touch it or cross it. Okay, so on WebAssign, they give you multiple choice. I still encourage you to do it on paper so that you can then compare your graph to the given choices. Okay, so now we go to a little bit of chapter 3, and it says use the properties of logarithms to expand the expression as a sum or difference. So notice here they give us just one log 5 of the square root of x squared minus 9 divided by 4. And so in chapter 3, you're going to see the different rules. So here we have this term divided by this term. So we can apply what we call the quotient rule. And the quotient rule says that if you're dividing two statements here, then we can separate them with subtraction. So we write log 5 of x squared minus 9 minus log 5 of 4. Okay. Now in chapter 3, if you have a square root, the square root can be rewritten as a exponent. And so that would look something like this. X squared minus 9 to the power of a half minus log 5 of 4. If you had a cube root, then it would be 1/3. If you had a 4 on the outside as your index, then you would be 1/4 and so on. And so since you have an exponent, we can use what we call the power rule. And the power rule tells us that we can take this exponent to the front of the log. So then I'm going to have 1/2 log 5 of x squared minus 9 minus log 5 of 4. Okay, so we went from, well, we can factor, let's factor x squared minus 9. So we end up with x minus 3 and x plus 3. These are being multiplied, so we can use the product rule and we can separate it with addition. So x minus 3, and then we have a plus, and then we have your x plus 3, and the half is applied to both of them. And so now we have, from one log, we were able to rewrite it with addition and subtraction in this case. Okay, so now I want to go backwards. So I want to go from here to one log. Okay, so that's what we're going to do here. So the best thing for me that I encourage people is to kind of start from left to right. If you have parentheses, then you want to do those first. So here I don't have parentheses, so I'm going to start from left to right. And then always check if you have a number in front of the log, then you want to deal with those numbers first. If they're in front of the log, that means that they used to be an exponent. So let's rewrite those. Okay, so we would get this 6, we would write it as an exponent, and this 7, we would write it as an exponent. And now the first log is being subtracted with the second log. So since you have subtraction, that means that we're going to change it to division using the quotient rule. So we're going to have x divided by y to the 6. And then I have plus log z of 7. Since I have addition, then I'm going to combine them using the product rule. which we're going to be multiplying. So we're going to have x divided by y to the 6 times z to the 7th. Simplify. So we end up with log x times z to the 7th divided by y6. And that would be our condensed expression. Okay, let's try B. So for B, notice we have some parentheses involved. So let's see here. So here they actually want us, okay, let me go back. So this right here is a little bit, I guess it's this one over here. So let's do this first and then we'll come back to this one. So natural log of x minus natural log of x plus 6 equal to 7. We want to solve for x. So notice that they're being subtracted so we can combine them with division. So x divided by x plus 6 is equal to 7. And then we're going to change it to exponential form. So ln, so this is an L. ln is the same as saying log e. So the base is e. And to change it to an exponential function, we write the base, which is e. And then the log is always equal to the exponent. So since this log is equal to 7, that means that 7 is your exponent. And then we have x divided by x plus 6. We're trying to solve for x. So we're going to multiply by x plus 6 on both sides. So we end up with e to the 7th times x plus 6. Simplify. Okay, so we're going to distribute e to the 7 times x is e to the 7x. E to the 7 times 6 is e to the 7 6 is equal to x. So we want to put all the x's together. So let's move this x to the left by subtracting it. So we have e to the 7x minus x. And then let's move this term to the right by subtracting as well. So we have negative e to the 7 times 6. Since I have an x and an x here, I can factor out an x. So we end up with, if I take this x out, we end up with e to the 7th. And if I take this x out, I end up with e to the 7 minus 1. Now we can divide by e to the 7 minus 1. So we get x is equal to e to the 7 times 6 divided by e to the 7 minus 1. And if the problem does say to approximate to 3 decimals, so if I put this in my calculator, then this is approximately negative 6.005. And so this little picture here shows you how I entered it. And notice I have parentheses everywhere. So make sure that you practice with your calculator so that you can see where you need the parentheses, or you can do it one at a time and then write down your numbers. But I encourage you not to round until the very end. Okay, so once you get a solution, what we think is a solution, we need to check our work to make sure that it is a solution. And so if I put here in place of x, we said that x is approximately negative 6.005. So if I plug that in for x, the natural log of a negative 6.005, we cannot have the log of a negative number. Because of that, then we say that there's no solution. Okay. Let's try letter B. So here we have natural log of x plus 9. I'm going to combine the right side. So here is subtraction. So I'm going to be dividing x minus 6 divided by x plus 6. Since I have the same natural log on this side as the one on the other side, we can use the one-to-one property. And the one-to-one property tells us that if you have the same log with the same base, then we could set x plus 9 equals to x minus 6 times divided by x plus 6. If I solve for x, I'm going to multiply by x plus 6 on both sides. And then let's continue simplifying. So x times x is x squared. X times 6 is 6x. 9 times x is 9x. 9 times 6 is 54. And then we're going to gather our like terms. So we get x squared plus 15x plus 54 is equal to x minus 6. This is quadratic, so we want to bring everything to the same side. So I'm going to subtract an x, and I'm going to add the 6. So we end up with x squared plus 14x plus 60 equals 0. It's quadratic, so you can use the quadratic formula, or you can try to factor. And so here I went ahead and used the quadratic formula. So the quadratic formula, b is 14, so I get negative 14 plus or minus b squared, which is 14 squared, minus 4 times a is 1, and c is 60. So if we multiply out, we get 196 minus 240, which we end up with a negative 44. And since this is going to be an imaginary solution, then we say that there's no real solution. Okay, let's try one more. So here I have two logs with the same base, so they're being subtracted, so I can combine them by division using the quotient rule. So I have x divided by x minus 8 is equal to half. We're going to change it to exponential form. So my base is 9. The log is equal to a half. That means that half is a power, or the exponent. And then we have x divided by x minus 8. 9 raised to the half is the same as the square root of 9. And so we can continue there. So we get plus or minus 3. And then we can multiply by x minus 8 on both sides. So I get 3 times x minus 8 is equal to x. And then we use the negative one. Negative 3 times x minus 8 is equal to x. And it's simplified. 3 times x is 3x. Minus 24 is equal to x. Subtract the x, we get 2x. And so x is 12. And on this side, if we subtract the x, we get negative 4x divided by negative 24, which is going to be 6. So 12 and 6 are potential solutions. So let's check if they work. So if I plug in 12 for x right here, that's positive, that's okay. And 12 minus 8 is 4, so that's positive. Notice they're both positive. So that means that 12 is a solution. And if I plug in 6, I get a positive 6 here. But 6 minus 8 gives me a negative 2. So that means that x equals 6 is not a solution. So the only solution is going to be x equals 12. Okay, so if you want a copy of this PowerPoint, right here where I'm pointing, there's a little box with an arrow pointing down. If you click on that, it'll let you download the file. And then also in the chat, they've been putting some links up there. And one of the links is to the YouTube channel. So if you are taking a 10-week class, I do encourage you to go to that YouTube channel and look up the spring happy hour sessions. And you can find them based on what you're doing right now. So for those of you taking the 10-week class, you're in chapter 2. If you go in there, you'll see all the happy hours for chapter 2. And then starting next week, you'll see the chapter 3 ones in there. But you can find them in our YouTube channel. And I guess that's it for today. If you have any questions, let us know. And thank you for coming to Friday Happy Math Hour.
Thank you very much, Miss Ivechuka, for your wonderful presentation. If you would like to download a copy of the presentation, as Ms. Chuka said, you can go up to the top right corner and click on the box with the arrow going down while the presentation is still on the screen. We do want to remind you all about our previously recorded sessions, which are available on YouTube playlists. This session will also be available on the playlist later today. Also, there's a link on the short survey to help us improve our TVE sessions. Please take a few minutes to fill out this survey. And before we leave, I want to share the TV sessions that we will be having next week. Please join us next week at 1 o'clock for the free learning resources for TSIA 2 and the TEAS test prepping. This is going to be the last Happy Math Hour session we will be conducting for the summer semester. We will be back for the fall semester, but please join us for the 1 o'clock semester next Friday on July the 14th, where we will be exploring free learning resources for the TEAS and the TSIA 2 with the prep program. Thank you very much. And if you have any questions, you can go ahead and post any questions on the chat box. We hope to see everyone again soon next week. And happy math hour.
If you're in my class and you want to attend next week for the 1 o'clock, you can just sign in and I'll still give you the credit since there's no more Friday happy hour. But if you want to join them at 1 p.m., then you can.